So, our third speaker this session is Jasmin Diab, who describes herself as a mum, leader, nerd, big nerd, that's from me, and diversity advocate. She spent about 22 years in the Australian Army, where she specialised in countering chemical, biological, radiological, nuclear, and explosive threats. So, when most of us will run away, Jasmine will run to the threat to try to counteract it. So that's a good effort. She now has multiple roles, including as the managing director of Global Nuclear Security Partners and is the president of Women in Nuclear Australia. So today is going to talk to Jasmine about something that I've personally been wondering about for some time, and that is the opportunities and challenges in the field of civil maritime nuclear propulsion. Jasmine Diab, everybody.
First of all, I'm really excited to be back in the Eora Nation. I moved across to Perth in December, and so it's nice to come back to Sydney, where I've got a lot of friends. Thank you to Mark and John and the ANA Conference Committee for allowing me to address commercial maritime nuclear, because nuclear for civil propulsion has been of interest for decades because it has the potential to provide zero emissions alternative to conventional fossil fuel powered vessels. However, most nuclear propelled ships today are all military or government owned. They're submarines, aircraft carriers, or icebreakers, which means they're state owned and operated and regulated. So the idea of commercial shipping is actually an interesting one because it provides a heap of challenges from a regulatory side. So, why does commercial shipping sector matter? As you can see from the slide there, oil based fuel has met over 99% of the total energy demand for international shipping. According to the OECD, global commercial shipping accounts for 3% of global energy related CO2 emissions. In response to this, the International Maritime Organization, or IMO, has set emissions reduction targets that align with the Paris Agreement to see commercial shipping emissions reduced by 50% by 2050. And that's pretty soon. However, all the modelling they've done so far to support this strategy has explored limited options, including biofuels, ammonia, hydrogen, and methanol. And as you can see from the far end of the slide, it really has a small impact on the reduction of carbon emissions. So, nuclear has been thrown into the mix. Nuclear propulsion at sea can provide not only carbon free emissions, but also increase speed and endurance for shipping fleets. The technology's proven. We've just had two speakers talk about it. It's been used for well over 70 years. However, because this technology has been reserved for government owned, operated, and regulated vessels who inherently have armed security embarked, this now raises the questions on the practicalities for regulation, nuclear safety, security, and safeguards, especially when privately owned vessels are often flagged in countries that do not have any glimmer of a nuclear program, which means they don't have a reputable regulator. There are so many opportunities for civil nuclear shipping or floating nuclear power plants. First and foremost, really, is the reduction of CO2 emissions. But it's not just that. In addition to carbon, nuclear ships would reduce emissions of sulfur oxides, nitrogen oxides, and particulate matters, improving air quality and reducing ocean acidification. Next is energy efficiency and range. Nuclear power ships have significantly longer ranges compared to conventional ships and cooperate for years without refueling, which is especially advantageous for super long haul fleets like Arctic shipping or remote regions where refueling infrastructure is a bit limited. They have higher efficiency. I don't need to tell anyone here about the energy density of uranium compared to fossil fuels, but this now means that ships aren't having to carry fuel on board, so they can carry more cargo, dedicating space to carry more, which makes it more economical from a commercial shipping perspective. That energy security and stability means they now have reduced reliance on fossil fuels, which again brings down prices for commercial shipping with fluctuating oil prices, which has long term cost stability for shipping. It also allows for some strategic independence, but this again is with a big question mark. Where is that ship flagged? Do they necessarily need that independence? meaning nations might be able to reduce their reliance on other shipping fleets to ensure their security of imports and exports. But this is not just limited to commercial shipping. Floating nuclear power plants to support green hydrogen and ammonia production, if that's what you're into, and nuclear powered ships could serve as mobile plants in ports or places where there's been devastation or emergency power. And finally, is the support uh, to small modular reactor and micro reactor technology. Maritime nuclear provides a really interesting perspective on how to generate that kind of power in a maritime environment, how to make it safer, more efficient, easier to maintain, more secure, and have safeguards implementations designed built in. But the list of challenges is also long. There are many, many opportunities, but there are many, many challenges. Firstly, is centered on safety. While the nuclear reactor on board a civilian ship might not be the most high risk part of the vessel, safety is a significant concern. Since the birth of nuclear propulsion at sea, there's only been a handful of reported incidents, predominantly with Russian vessels. However, the public perception of nuclear is still a significant challenge, especially if you talk about a nuclear ship running aground or sinking or snapping in half. So they're things that need to be addressed. Next to the security challenges, something near and dear to my heart as a nuclear security professional. Nuclear powered ships now become targets for pirates or terrorism, posing risks of theft of nuclear materials or potential radiation contamination. These security threats require robust international regulations and security measures, but can also be avoided by avoiding high risk areas or choke points or vulnerable routes that reduce that that can be reduced because you're no longer concerned about consumption of fuel. You have everlasting fuel essentially. Safeguards also is a significant challenge from a non-proliferation perspective. Where vessels are flagged, who's in control of them, who's assuring that material is being used for peaceful purposes, especially whilst refueling or in the decommissioning stage. Then we have the regulatory and legal barriers. There's existing maritime law, UNCLOS. I'm not a Navy person, so I'm not going to describe UNCLOS, but it does not comprehensively address the operation of nuclear powered civil shipping. I'm going to talk a little bit later about what the IMO already has in place, but this needs to be addressed. And much like safeguards aspects, nuclear waste management is a challenge. Where does the fuel used from the ships get either recycled or disposed of? Who is in charge of that? Does the ship owner own the reactor and therefore they're responsible for it? Or do vendors provide these reactors for commercial shipping and then they take responsibility for it? Even though these ships will not require a lot of refueling, the disposal of that spent nuclear fuel is an issue that needs to be resolved. Port access and infrastructure. Not all ports will be capable of dealing with a nuclear powered ship. And a lot of those ports might not want nuclear powered ships to come alongside. So, how do you deal with that infrastructure? And then lastly is liability and insurance. Not insurance or assurance, but insurance. Who insures these ships? They're already quite expensive to run, and establishing frameworks for liability and insurance are critical for the feasibility of nuclear shipping. Whilst these challenges are quite long, they're not insurmountable. And significant effort is being put in by the commercial shipping sector to test the viability of nuclear as a power source. So the IMO had considered this in the past. Nuclear shipping had a supplement to the International Convention on Safety at Life at Sea, and it was written in the 1970s and adopted as a resolution in 1981 as the Code for Safety of Nuclear Merchant Ships, or the Nuclear Code. The resolution was really limited, prescribing requirements for ships using early designs of pressurized water reactors and a direct steam propulsion system. So it didn't give much in terms of flexibility on the technology. It was originally designed to be updated as the technology was updated, but it actually hasn't been updated since 1981. So this is quite outdated and needs to be aligned with IAEA standards. There's also the Convention on the Liability of Operators of Nuclear Ships, published in 1962. This is the legal framework in the event of a nuclear accident at sea. Again, This is quite outdated and has been overrun by technology, so it needs an overhaul as well. And finally, the safety recommendations of ports by nuclear merchant ships, published in 1968, which was an intergovernmental maritime consultative organisation, and the IAEA. This publication was giving governments and port authorities access to the information they needed to see if they had the right infrastructure and the right emergency response teams if they had a nuclear ship come alongside. Again, very outdated. So, in response, the Nuclear Energy Maritime Organisation was developed in early 2024. It has the best short title, NEMO, really cute name, nice pink and black. But it's looking at the practical applications of new nuclear solutions deployed in the maritime sphere. NEMO has international membership from stakeholders involved in all aspects of floating nuclear, with a view that the deployment of floating nuclear is vital to allow for full decarbonisation of some of the most challenging sectors of the global economy in transport and shipping. NEMO's mission is to establish a harmonised regulatory framework that allows for a floating nuclear demonstration by 2030. So it's quite ambitious. You can see from the current membership, it covers nuclear vendors, developers, commercial shipping companies, port authorities, shipyards, law, insurance, and regulatory assurance companies. And these members are all working together to understand the opportunities and challenges in this space. You can also see a really cool logo of GNSP in there, pretty biased, but we look at the nuclear security aspects. NEMO plans to help national and international regulators create appropriate frameworks and structures that allow some rules for deployment, operation, and decommissioning of floating nuclear power, allowing these solutions to be deployed with the highest standards of safety, security, safeguards, and environmental justice, with a commitment to advance the safe and secure and sustainable integration of nuclear technology at sea. So, to do this, they've started out with three initial working groups. GNSP is the co chair of Working Group 2, which is Nuclear Safety, Security and Safeguards. But as you can see there, there's also a working group that focuses on maritime regulations, making sure that it aligns with current IMO standards. And then there's a group in Working Group 3 looking at the maritime nuclear liability portion, because that will be quite an expensive venture on its own. In the future, there'll be two more working groups that are established, one that looks at seafarer training regimes. So, how do you build that workforce up? And then the next one that'll look at ports and interfaces to make sure that infrastructure, emergency response is all appropriate in the right kind of ports. But for this to become a reality, extensive international cooperation is required, and investment in technology, safety, security measures will be necessary. You can see from the timeline here that NEMO is really pushing ahead in trying to integrate the right identifications of gaps in the current systems, find how we can fill them with new regulations, and get on board with both IMO and IAEA to establish a decent regulatory framework for civil nuclear power. So, commercial shipping is not stopping. It keeps us all interconnected and allows for a global economy. You can see from the slide there, these are the current global shipping lanes. And I like to pose the question, could nuclear commercial shipping change this landscape? Could we reduce the number of choke points and vulnerabilities because fuel and endurance is no longer an issue? Um, Nuclear powered commercial shipping presents significant opportunities, particularly in terms of reducing our carbon emissions globally and enhancing our energy security. Tech advancements in small modular reactors and microreactors could really make nuclear shipping more feasible. However, before we can do any of this, we really need to have the right regulatory guidelines, legal frameworks, and barriers in place. That's it from me. I've got up there the NEMO website if you're interested in finding out more or wanting to become a member. Um, but this is a really exciting space to see how we can change up some of the transportation sector, which is some of our biggest carbon emission producers globally. Thanks.